Happy New Year sa lahat. Welcome na naman sa ating virtual classroom. So dito nagbibigay tayo ng mga lectures and tutorial videos on iba-ibang engineering subjects. Sa ngayon meron tayong ito, strength of materials, and then meron tayong konting statics and hydraulics. And nagdagdag din tayo ng isang playlist for Geographic Information System or GIS. But as of now, Q pa lang yung tinuturo natin, Quantum GIS, kasi nga mas open source, kaya madali lang i-download and mas madaling gamitin compared din sa isang commercial version na ArcGIS. Anyway, balik tayo dito sa strength of materials. For this lesson, for this video, we'll be discussing the area moment method, which is another method in calculating your beam deflections. So, tapos na tayo sa double integration method. So, ito na yung next. Ang area moment method is very dependent on your moment diagram. So, kailangan mong gumawa ng moment diagram ng yung beam, considering your loads, saka ka lang makakagamit ng area moment method. So, for example, meron kang beam na span ay AB. So, ito na yung maging moment diagram mo. Actually, meron tayong M/EI diagram. So, yung moment diagram mo, i-divide mo lang ng EI. So, yung flexural rigidity, EI. So, E is, again, the modulus of elasticity, and then your I is your second moment of area of a shape. So, sa cross-section mo to, or your moment of inertia. So, ito na yung magiging M/EI diagram, and then the CG here is the center of gravity. So, ito yung centroid ng area mo. So, yan. And then the X bar is measured from B to A. So, malalaman natin mamaya, yung reference point mo from A or B ba, dito sa equation natin. Especially dito. Okay, so, yan na yun, moment diagram, M/EI, tapos X bar, measured from point B to the center of gravity or centroid. Yun naman yung X bar. And then, dito sa drawing na to, meron tayong elastic curve. So, again, ito yung beam natin, span AB. And then, ito yung elastic curve, yung broken line. And then, ang nangyayari sa area moment method, gumagawa tayo ng tangent lines. For example, gusto nating malaman yung deflection somewhere here. Gumagawa tayo ng mga tangent lines at any specific point or variable na point along our elastic curve. So, for example, gagawa tayo ng tangent line from at point A and point B. So, ito yung magiging intersection nila. Ang theta AB natin, which is the angle from A to B, from tangent A to tangent B. Again, yung tangent ay it's a line passing through a curve at a single point. So, ibig sabihin, at point B, isang tangent line yung magagawa mo dyan. Ganito yung direction ng tangent natin kasi ang curve natin from A is pag ano. Pag sa maximum deflection ka, for example, dito sa gitna, ang tangent mo ay pag ganyan, horizontal. Horizontal. Kasi, yun nga, isang point lang, the tangent line passes through at a single point sa yung curve. So, yun nga, yung theta or yung slope AB is just the angle measured from tangent A to your tangent B. Take note na counterclockwise is positive. So, yun yung sign convention natin. Pag slope, and then your distance, itong theorem 2 natin is the perpendicular distance, perpendicular from the direction ng beam. So, for example, kung horizontal yung beam, ito yung distance na perpendicular, which is vertical, from point B to your tangent A. So, ito yung T, B, A. So, parang T is the distance from point B to tangent A, which is equal to your area of the moment diagram times X bar. Okay? So, yung area of moment diagram mo ay area of moment diagram over EI. So, may EI na yan. Ito. Bali, in-emphasize ko lang na yung A dito ay hindi lang area ng moment diagram, but area ng moment diagram divided by your flexural rigidity. Dito naman, meron tayong A times X bar. So, dito na magagamit yung direction natin. Pag T, B over A, the x bar is measured from B to your center of gravity. B over A. And then the point over your tangent A. Sa sign convention naman, pag ganito yung figure, point B is above tangent A, that's positive. Minsan kasi nangyayari na nasa taas yung tangent. For example, yung elastic curve mo ay pag dito, no? Ibig sabihin, yung force, yung external loads mo ay upward. So, ibig sabihin, ang deflection ng beam mo ay dito, no? Concave downwards. So, ang tangent line mo ng point A, for example, is nandito. Point B to tangent A, that would be a negative TB over A. So, yun yung sign convention. No? So, ito lahat yung positive natin na sign convention. Counterclockwise is positive slope. And then, if the point is above your tangent, then positive din yung TB over A. So, again, variable yung point natin na A and B. No? It can be anywhere sa yung elastic curve. So, paano nga ba natin nasa-solve yung deflection? Kasi ito, hindi pa to deflection. Take note, hindi pa to deflection. Ito, slope na. No? Pero yung deflection, hindi siya equal agad sa T, B over A. May special case lang na equal na agad, no? Yung para sa cantilever beam natin. Pero sa mga ganitong cases, hindi ito agad yung deflection. Ang mangyayari, gagamit tayo ng similar triangle. No? Yung concept ng similar triangles, for example, makukuha natin yung T, B over A dito. Makukuha din natin yung for example, dito, kukuha din natin tayo ng, for example, at point C, TC over A. So, meron tayong similar triangle na itong malaking triangle, tapos itong isang maliit na triangle na ang height nito ay magiging equal sa TC over A at yung deflection. So, ganun. Anyway, papakita natin yung application ng concept. Basta ito lang, no? Ito lang yung tatandaan natin na slope equals the area of moment diagram divided by EI. And then yung TB over A is A times X bar, where X bar is measured from point B to your center of gravity. Okay? So, example tayo. Okay, so ito na yung example natin. Meron tayong beam dito na ABC. Pin supported at A, and then we have a roller support at point B. And then you have a 10 kN load at point C. Ito yung dimension, 6 meters and 3 meters. So pag gagawin natin yung free body diagram, meron tayong reaction at B, meron din tayong reaction at A. So in-anticipate ko na downward yung A kasi pag nag-moment ka dito, ang moment na cause ng external load natin is clockwise. So dapat meron tayong counter moment na mangyayari dito. No? So in-anticipate na natin na downward yung A. So for this particular problem, ang required sa atin is yung deflection and slope at point C, which is dito yan. So, gagawin natin dito first is kuha tayo ng reactions. Yung reaction at point A and reaction at point B. So, summation of moments tayo at point A para makuha yung reaction at B. Gagamitin na natin yung direction ng moment ng B, no, at relative to A para positive na agad siya. So, moment arm ng RB is 6 meters. And opposite direction naman yung 10 kN, which is clockwise. Ito ay counterclockwise. Moment arm naman is 6 plus 3, which is 9 meters. Okay? So, RB equals 15 kN, which is upward. And then, summation of forces tayo. Meron tayong upward na 15. Meron tayong dalawang downward na forces, which is 10 plus RAY. So, RAY, therefore, is 5 kN, which is directed downward. Next natin is yung shear and moment diagram. Kasi nga, ang sabi natin kanina, yung area moment method natin is sobrang dependent dito sa moment diagram natin. Gagawa tayo ng shear and moment diagram. So, sa shear, first, meron tayong reaction na 5 na downward. So, ibig sabihin, meron tayong negative shear. Tapos, wala namang nangyayaring loading dito sa from point A to B. So, straight lang yan na negative 5 hanggang sa mag-add tayo ng 15 sa reaction at point B. So, negative 5 plus 15 is positive 10. Tapos wala ulit nangyayari dito. And then you have another load na negative or downward. So 0 na yung or 10 yung 10 kN papuntang 0 dito. So that's it, no? Sa moment diagram naman
natin, meron tayong 0, and then you have a negative shear area, which is negative 5 times 6 meters, so that's negative 30. 10 times 3 is 30, so magiging 0 ulit. Wala kasing moment dito sa free end natin. Wala ding moment dito sa ating support at A kasi pin support. So ito na yung gagamitin natin na moment diagram. Madali lang, no? Pag kukuha tayo ng area mamaya, triangle lang. So anyway, ang next natin na gagawin is isolve yung deflection and slope at point C. Ang next na gagawin natin is to illustrate our elastic curve. So ito na yun. And then the required natin is yung deflection at point C and slope at point C with respect to the horizontal. So gagawin na natin yung area moment method. First ay gagawa tayo ng tangent lines. So ito na yung tangent line natin at point A, passing through point A. And then you have the tangent line at point C, passing through point C. Ito na yung T, C over A, T, point C over tangent A. Ito na rin yung T, point B over tangent A. Ito yung slope natin, C over A. So counterclockwise again is positive. So ito yung slope between tangent C and tangent A. And then ito yung slope natin ng point A with respect to your horizontal. Yan, no? Ito yung slope C is naman slope A. Okay, so solve na natin. We'll start with angle C over A. Area of moment diagram lang naman yan, no? We have CA is equal to 1 over EI moment from C to A, which is equal to 1/2 triangular area lang naman yan, no? Yung kanina na ganito, which is 30, tapos meron tayong base na 9 meters. Okay? So you have 1/2 30 times 9 over EI, which is equal to 135 kilonewton meter square divided by EI. Meter square kasi itong 30 na kilonewton na yan times meter times pa ng meter, kilonewton meter square. Next ay yung TBA. You have T B slash A, which is equal to, the equation natin, you have the A times X bar. So, i-analyze natin yung triangle AB. So, this is point B, this is point A. Ito ay 30. So, since T natin is from B to A, so point B to A, ang X bar natin is reference at point B. So, papunta dun yung X bar natin. This is X bar from point B to tangent A. Yung X bar natin, if triangle yung area natin, is 1/3 sa distance na to, which is 6. So, that's 2 meters. So, 2 meters yung X bar. Then, yung area natin dito is 1/2 base times height. So, this is X bar. 1/2 base times height na 6 meters. This is 90 kilonewton meter square divided by EI. X bar is 2 meters. So, magiging answer natin dito is 90 times 2. That's 180 kilonewton meter cube divided by EI. Okay? Meter squared times M equals meter cube. Yan. Di pala masyadong nakita kanina. So, yan. So, meron na tayong TB over A and meron din tayong slope C over A. Next is yung TC over A. So, area X bar. Analyze lang natin yung triangle from A to C. This is 30. This is 3 meters. And then this one is 6 meters. Medyo mahirap kasing kumuha ng centroid or yung x-bar pag ganitong triangle. No? Mas mabilis pag i-divide natin yung triangle na to into two right triangles na para 1/3 dito, 2/3. Again, yung TC over A natin is yung reference point ng ating x-bar is from point C. So, yun yung dapat niyong i-remember. No? That's the x-bar should always be referenced from your numerator, yung C. So, i-divide natin yung area na to into two right triangles. Area 1 and area 2. So, for area 1, we'll have 1/2 base na 30 times height na 6 times yung x-bar natin since dito natin i-measure yan. X-bar 1. Ito yan, that's x-bar 1. So, 1/3 plus 3. So, you have 1/3 of 6 plus 3 meters. So, ito yung A1. Ito naman yung x-bar 1. Okay? Plus, yung second area natin, which is 1/2 times 30 times 3. Yung x-bar 2 natin is dito lang, no? 2/3, which is based from point C. So, you have 2/3 times 3. So, again, ito yung area 2. Ito naman yung x-bar 2. Okay? So, total answer nito ay i-add lang natin. Meron tayong 6 divided by 3, 2 plus 3, 5. Ito naman ay 390 times equals 5 times 5. Ito, so 90 times 5, that's 450. Ito naman, meron tayong 15 times 3, 45 times 2, 90. So, 450 plus 90, that's 540. 540 kilonewton meter cube over EI. So, meron na tayong TC over A, TB over A, at saka angle or slope C over A. Ngayon, paano nga ba natin makukuha yung slope at point C given yung mga values natin na na-compute kanina, no? Kung i-analyze natin yung angle C over A, ganyan yan, di ba? So, this is angle C A. Kung mapapansin nyo rin, yung angle natin na A is actually based on the horizontal. Yan yan, no? This is theta A. Ito na mga theta C natin is also based from the horizontal, which is ito. This is theta C. So, para ma-solve natin yung theta C, which is the required for the problem, sasubtract lang natin yung slope A from your slope C to tangent A. So, kukompute muna natin yung theta A. Pwede pa natin i-compute na lang dito, no? So, magagamit natin yung triangle na ito, no? From T, B over A, papunta dito, which is 6. So, theta is A is just actually kung opposite over adjacent, that's tangent negative 1 of yung TB natin is 180. That's 180 divided by 6. Diba? This is 180 kilonewton divided by 6. Tangent negative 1. So, ang theta A natin is 30 kilonewton meter square divided by EI. Kasi for very small angles, ito, exaggerated lang naman yung deflection line natin, no? Theta A actually is a very small angle, so magiging ano lang yan, no? Theta A is approximately 180 divided by 6. pag tangent or sine, yun yung mga nangyayari, no? Pag masyadong maliit yung angles, nai-equal na siya dito, no? Konti lang kasi yung difference pag tangent negative 1 mo pa at saka yung 180 divided by 6. So, theta is just 30 kilonewton m square. Kasi ito m cube, tapos ito naman m. So, makakancel yung isang m. So, meron na tayong theta A. Makukuha na natin yung theta C as the difference between slope CA minus slope A. So, you have C is equal to CA minus slope ng A. So, C equals, saan nga ba yung C natin? You have 135. Pareho lang sila ng units. So, you have 130 kilonewton m square over EI minus A, which is 30. Ang unit natin is kilonewton m square over EI. So, we have theta C is just equal to 105 kilonewton m square divided by EI. So, meron na tayong slope at point C. So, parang ano lang, no? Trigonometry tsaka geometry na pinagsama. Dapat lang i-imagine lang natin yung figure natin. So, ngayon meron na tayong slope. Next na kukunin natin is deflection. So, ang deflection natin is, ito yun, no? Pag titingnan natin yung drawing, ito actually yung YC. So, sulat natin para mas ma-imagine. This is actually your YC, no? Or the deflection at point C from your, na ba tawag doon? Yung neutral axis ng beam. So, paano ba natin makuha yung YC? Meron tayong TC over A, meron tayong TB over A. Pwede tayong mag-similar triangles actually, no? Ito, tsaka, yan yung dalawang triangle na yan. So, we have TC over A by similar triangles. Meron tayong ito, at saka ito, na triangle, no? Hindi nakikita, no? So, ito yung triangle na mas malaki, tsaka yung triangle na mas maliit. So, ang triangle na mas malaki, meron tayong TC over A minus YC divided by 9 meters. Minus YC kasi, ito yung TC over A mo, di ba? TC over A minus YC, ito na yung length ng ating triangle. Ganyan. So, meron tayong ito ay TB over A. Ito naman ay magiging TC over A minus YC. Kasi ito yung YC mapunta dito. Okay? And this is 9 meters. Ito naman ay 6 meters. Ito ay 3 meters. So, mas maliit na triangle, you have T divided by 6. So, evaluate lang natin to. Given naman yung TC over A natin, which is 540. So, we have 540 minus YC over 9 equals TBA, which is 180 over 6. So, YC equals, so, times 9, 180 divided by 6, that's 30. Times 9, that's 270. So, 540 minus 270, that's 270 din, no? Tama ba? 180 divided by 6, that's 30 times 9, 270. 540 minus 270, that's 270 din. So, 270 kilonewton. Ito ay m squared divided by 6 meters. M cubed divided by 6 meters magiging m squared. Divided by EI. So, ito na yung deflection natin at point C, which is directed downward. Okay? Ito na yung first example natin for area moment method. So, gagawa pa tayo ng additional sample problems para mas maintindihan pa yung method na ito, no? Area moment method. Kayo na mag-decide kung saan yung mas convenient gamitin, yung double integration method or yung area moment methods. Anyway, thank you again sa pakikinig. I hope na may natutunan na naman kayo sa ating discussion. Pag meron tayong sakali may mga mali-mali or medyo hindi clear yung pagka-explain, comment lang, tapos discuss natin sa comment section kung pwede. So, thank you again.